Hey quad folks, today I am tracking down a short to ground on one of the old blackface modules in the old RCA TR70. This is one of the classic RCA problems that you encounter once in a while with the old RCA blackface modules out of the TRs, 60s and 70s. And what happens is when RCA would assemble these dual circuit modules, you'd have a circuit board on one side and then you'd have a circuit board on the other side, and between them you would have a little ground plane, which is basically just a piece of copper that's been insulated on each side by a piece of mylar. And what happens once in a while is there'll be a one of these little circuit stakes that the components solder to. This is all old school stuff, point to point wiring. And so instead of having, a lot of copper traces that you would have on a circuit board, they have these little circuit stakes, and then the components are soldered across them, and then the connecting wires connect the points of the circuit together rather than a copper trace. Most of the time there are some copper traces used, but not a lot on these old boards. Well, these little stakes are just pressed into holes on the PC board, and here's a couple. The back side, you see where it's been pushed through and then it's been braided in there, so it won't come back out. Those little ends, the edges, where it's been rolled over and braided into the hole, sometimes there's a little sharp point there. Or other times the stake will fill up with solder and there will be a little solder bead on the back instead of it just being a hollow piece. And of course the solder is molten hot, and that tends to sometimes it can melt through the little insulating mylar layer and make a connection with the copper ground plane. And so that's kind of a built-in problem that these old blackface modules have, which once in a while something will bite through, or maybe something will get a little too hot when you're soldering and it'll melt, a little bead of solder through the back side and melt through that insulating layer into the copper. And of course, the copper itself is grounded to the frame, you know, where the mounting bolts are for the printed circuit boards, and of course there, that's, you know, that's a ground to the chassis. And that was done, you know, for shielding, signal to noise ratio, and EMI, RFI interference shielding. And of course, it was a good idea back in its day, but these things are 55 or 60 years old now. And so that problem arises once in a while. And you know, it'll be kind of interesting if we could go back and ask some of the designers at RCA about all this. Back in the day, they probably had no idea that these things would still be around 55 years later. Doing archiving transfer work. Anyway, our problem on this board, this is one of the playback amps for one of the FM channels of the video. And what happened was the minus 20 volt regulator, the emitter had no voltage on it. So we were bringing the minus 20 in off of the power supply rails and on our collector, and then it's going out on the emitter as minus 12, so it's stepping it down. Well, we had minus 20 going in, but we had 0 going out. And so you would normally think, well, the transistor's open, or maybe the capacitor is shorted to ground, or maybe the zener has gone kaput. Well, as it turned out, none of the above. So we have the capacitor's good, the zener's good, and the transistor's good. So, you know, at that point you start unhooking things and measuring, you know, for a short or something that's gone wrong. And so what we wound up doing here is taking the base loose, and looking on the circuits you can see here, see there's our minus 20 coming in from the bus, and there's our big resistor. And so we're good to here, and we're good to here with our R55. But here we've got 0, and here we've got 0. So in taking the leads loose to test the transistor, I also checked this lead off the base to ground. And what do you know? It was a dead-on short. So, you know, we have taken the capacitor loose and the zener loose and the transistor loose. And so that's out of the circuit, that's out of the circuit, and that's out of the circuit. And we're measuring 0 ohms to ground, so we're not going through that resistor, and we're not going through that resistor. It would be more than 0 if we were reading back this way. So something between here and here on the board has gotten to ground. And of course the main thing to suspect, you know, after you take everything else loose, is our little shield, you know, that's between the boards, our little copper shield and the mylar insulating layers. So what we'll do is we'll take some of these bolts loose and dig down into this a little bit. Now we've got the bolts out, and I have a little wooden stick here that I can pry these circuit boards apart. And let's see, we'll put our little lead back on the wire here. Okay, now if I squeeze them together, see, now we're grounded. And then you move them apart and that clears the short. So what I'll do is I have a little piece of mylar here. And this is 5 mil thick mylar. We can just chop a little piece of this off. see if we can work it back in between the two boards. Okay, now we have, which I don't know if you can see this or not. It's very hard to see because it's transparent. But we have our layer of mylar, our little squares covering up this whole corner here where we had the short to ground. So now let's hook our meter back up here and see if we can is I'm squeezing those two boards together. So if we have eliminated that short, and it looks like we have, then we won't see any indication on the meter. Okay, that's good. That's a good thing. Okay, that seems to have eliminated the problem. So now we'll put this all back together and give it a try. Alright, now we're all bolted back down and everything's tightened up as it should. And we'll give it the little pinch test here and see if we can make a connection. And we can't. So I would say that's a success. We have insulated the ground fault. Well, I would call that good. So now let's see, we'll solder our wires back on and take it over to the machine and give it the real test and turn the power on. See what happens. I really do like working in the old RCA. It's truly is old school, point to point wiring and all handmade. This was not made by a machine. Somebody actually assembled this. It's relatively simple, and I guess in a way it's limited, as to how the complexity that you would think of, that you would have with integrated circuits or even printed circuits. The complexity that you can achieve with some of that. But this is, I guess, a throwback to an earlier time, before all that. So there's something nice about it. I've always enjoyed working on the old RCA equipment. Just for that very reason of its simplicity in construction. All right, we'll give this another test just to make sure we didn't melt through the new insulator. Wouldn't that be something? Nope, we're good. Yeah, so we're measuring about 275 ohms now. And that's more of a normal reading instead of 0. Okay, let's go over to the machine and plug this thing in. See what happens. Stick this thing in and try it out. I'll move you a little bit so you can see what's going on. Now we should be able to what we can do here, I guess, first thing is we can use the head tester in the machine to check that module. Let's see, I'll position you here so you can see a little better. Got our probe on the head, and we go to response, and we're going to module number 2. Select number 2, and if we push our test button here, we get a response curve on our scope. Looks like we got all 4 channels again. Well, it looks like it's fixed. Well, I hope you enjoyed this little 2-inch adventure. It's just a little sampling of the troubleshooting and repair work that goes into bringing one of these old dinosaurs back to life. And it's just a lot of fun sometimes. I hope you enjoyed it. Thanks for watching.